Hello. We're gonna get started here today, doing some work. So I'm looking at what we're gonna be working on. Looks like there's a few things we need to do. So we need to rig up some obstacles. And then we need to work on 2D animations being played for our characters when moving. We also need to fix Fat Sack's animations. We need to do that. So why don't we start off with fixing those animations. So let's see, what exactly do we need to do for these animations for this guy? Well, we need to go through and make sure that all the animations actually have the proper sizes for the fat sack. So let's see, we're definitely going to need a little bit more than what we have right now. So I'm thinking something like a box kind of like this. I think that'll probably do for pretty much everything. So we need the 1x1 box, and it should be at, looks like 1.0. Is it -1? Not -1, is it -0.9? Yeah, it looks like -0.9 and then 11.5? Nah, it should be not 0.9 either. Wait, 8? That looks like a pretty decent box for everything. So let me just write that down real quick. This needs to be a 1x1 box at 0.9, -0.9, -11.8. So let's go through and fix up all of our stuff. So that's the S idle. Let's do the S dig. And then the run idle. So the run idle looks like that. Alright. I want these to pretty much be the same, just because it's easier. Hello, Synachron. We're just working on rigging up our objects, starting with Fatsack, just getting his hitboxes actually set up how we want them, kind of in a more final form. This is not even his final form, but we're gonna rig it anyway. Alright. So yeah, rigging can be pretty boring. Basically what you gotta do is get a hitbox that's pretty much the right size on your character. It's best if the hitbox is completely consistent where it is. Well, at least the physics box. The hitbox can be different than the physics box, but the physics box is like what you can traverse and everything, and it's best not to change it even if it doesn't perfectly match the character. Because when you're moving around on stuff, having weird, inconsistent geometry kind of based on a character when it moves can be pretty frustrating to deal with as a player. So it's better to keep it as consistent as possible unless there's a real reason to change it. You know, like your character does something, you know, like if they duck or something, like obviously you need to change the hitbox and the physics box then, but if they're just doing some basic moves, keep it the same. Don't with any mesh loading, so that'd be importing like a 3D mesh into Unreal. Yeah, we've done a bit of that, and I do need to actually get to that in a little bit. I need to import what I think Adam had a pond or something that he threw in here that I should snag in Unreal. Like your own mesh loading? Yeah, back in college I wrote an animation controller and everything else where we were working in 3ds Max and needed to export everything as a .x file and then import that and read all the animations and all the texturing and all that stuff. Yeah, I did that. That was quite a long time ago. Well, I was just using the .x format, which is pretty old and I don't think anybody uses. Everybody was even using FBX back then anyway. I was kind of just doing my own thing though. Why, did you have any specific questions that... Why did I choose .x? I chose .x because DirectX had a viewer for it, and I had a programming book that had a little bit of... It was like C++ game dev programming back in college that I read, and it had some coding examples on how to load animation controllers from .x files, so... Pretty much just because I had a book that told me to do it. There was no conscious good decision. If I was doing anything today, of course, you know, use FBX, not .x. And that's what Unreal uses. That's what you can import nicely with Unreal is FBX from like MyLT and all that. I mean, I can go ahead and crack open MyLT and like show you what we can do to export and import a 3D object if you want. So I think those are all rigged up. So let's make sure to save that. Then let's Let's export him. Yeah, that all looks good. Yeah, the .x format really wasn't very good, but it had all the information I needed. Like, I could infer the texture name and the normals, and I got all the animation data and all that, and I could debug it just by double-clicking it in DirectX. The DirectX viewer back in like 2010 worked, so you could just see your model. So it was real easy to see if like I had screwed something up, or if the export was screwed up. FBX is pretty much the de facto format. FBX is something we used back, 10 years ago, and it's something we still use. So FBX is kind of the right, in my opinion, probably the right decision to go with that one, because that's pretty much what everybody uses. So we're going to double check that our export actually has the right stuff in there. I'm actually gonna re-export real quick just to clean up all this garbage. Well, I am unfamiliar with both of those pieces of technology. The importing stuff there, because all the game engines that I've used since college have just had FBX loaders, and FBX loading is something you kind of write once and then forget about, and then you just keep using the same thing for the next 20 million years. So let's take a look. Did everything actually export properly? Looks like we got our frames, we got our pivot. Physics body is looking correct. The width and height don't really look right, do they? This is the R idle. I think I would definitely expect the... Well, let's go ahead and import it and see what it looks like. Well, with compositing all of your materials and all your models and everything else, you don't really need absolutely everything out of your model formats. Basically, you need the animation data, you need all the basic blend stuff and all that from your 3D mesh and all that. But sometimes inside of your engine or your editor or whatever, your actual code, you want to swap out what textures you're using in which places anyway. So at some point, it doesn't really matter too much. If you get all that information, you're probably going to have a separate system that kind of overrides a lot of it regardless. So we're going to go ahead and re-import FatSack. So I'd go with whichever one, if your overall goal is to learn, then I would use the one that kind of lets you look more into it, which would probably be the open source one. Kind of see how it's actually working, and if the goal is probably to get a more complete implementation, use the FBX SDK. That's probably what I would go with. Alright, so let's take a look at FatSack and make sure that he's got the right collision data. So it looks like that's just wrong. Like, this does not look correct at all. So we're gonna have to figure out why that is. Why is... yeah. I think it's exporting wrong. That's hilarious, yeah. So why the hell, like, this is insane. This is just weird. Why is... Let me just concentrate on one at a time, one animation at a time. See why it is wrong. Let me just work on the stationary idle spray sheet. This guy. And the height looks like it's just wrong. Like 80 should be not 80. It's not right. So if we're looking at the stationary idle, it just, yeah, this just looks, this isn't right at all. But this is also not imported, so we have to re-import that. I did not save after the import. So it should look like this. And very clearly that's not correct. It's off by a margin that is odd. Like the center is proper, but yeah, so the scale, I think it's the math is wrong on the export. Something like that has to be true. So let's see, the body hit rect has a height of 80. So I'll have to check why that is. The stencil buffer? Pretty sure that's... Like, we use the stencil buffer to... Isn't that depth sorting stuff? Basically, like, when you're drawing your pixel, like, you're in your pixel shader. And I'm not, like, super graphics engineer, but basically, like, if you're drawing, you know, your screen here, and let's say you've got an object in the background. And you've got an object in the foreground. So basically what happens is, why are we drawing like the green chevron over the black thing in the background? Because when you're drawing 3D objects, you're not drawing them in any sorted order most of the time. You're not just drawing the black box in the background because it's further away. You're actually drawing them in any order at all. and inside of your vertex shader you transform your model into screen space and all that, and then in your pixel shader you're going over each pixel and drawing it. And I think when you're using the stencil buffer, you draw the depth of the pixel onto the stencil buffer, and that's how you do a depth test, is like when you're drawing this, like let's say you drew the black box second, so you'd see the green things there, and then you draw the black box on top of it. Each time you're in your pixel shader here, you'd actually check the depth of the pixel, and if that depth was greater than the pixel that was already written there, you don't write it. So it basically say, oh, this green pixel right here has a depth of 1, and I'm trying to write black with a depth of 2, and the black depth is greater than the depth of the pixel already there, so I'm not going to write that pixel to the screen. I'm just going to keep going. But I think that the stencil buffer is used for that. But you can use it for other graphical effects as well. Like we used it for portals in college for things. And it was really just the same thing, like which depth are you working on and all that. But it's pretty much, at some point there, it's really just whatever information is written to the texture. It's all just the math of what's there. So it really depends on what your rendering pipeline looks like. You could be writing whatever information you need to write to that buffer, and then you can use it later. Like I think when we were writing for the portals stuff, we were basically writing which world was being rendered, and then we were compositing them later. So you'd know which render target to take from to draw your screen. So we could render all of our world data to the stencil buffer. I'm pretty sure that's what we did, and then we had the different texture samplers in our pixel shader would take from the different world chunks to actually draw to the screen, and that way we could draw like the light world and the dark world and all those things. And the portal itself would actually, I think, draw to the stencil buffer, and then we could composite the image that way. So M height. So our scene resolution Y. What is our scene resolution in this? Our scene resolution is 1024. So maybe we're not actually supposed to be taking the scene resolution Y. We're supposed to be taking the scene resolution X divided by the units X. Maybe that's what we need to do. Yeah, because I'm pretty sure, like, I'd have to look more closely into it. Let me see if I can pull something up from ancient history long ago. See if this thing still works. Like this was our college project, and you know, we made portals and stuff like that. And basically, like, there are these freestanding portal things that you could make, and you know, like, it's drawing both worlds, and then it would combine the worlds, basically, I believe, in the pixel shader, so you could kind of see it. So when you're actually rendering this out, I don't remember the console commands for it, but you can actually look at like each one of the render targets with the correct stuff. And we have this like kind of effect around it where they're alphaed out, but it's actually a hard line. And let me see, we've got let me see, I think it's got to be one of these things. These are all pre-compiled. These are the older ones. What the hell is everything? I've got this code somewhere. Well, damn, it's not where I would have expected. Anyway, but basically what we were doing was just you draw one world, you draw the other world, and you'd use the stencil buffer when you were actually doing like your post-processing, and you draw to the stencil buffer, and it also had the depth in there, and you could do like a whole bunch of math stuff and basically figure out exactly which thing to draw. But it looks like I don't have everything that I really wanted with the shaders, because all these are pre-compiled. Because what I want to find is the we had a prototype proof of concept program that was like super simple. But I guess I'm not finding it, so that's just how it goes. It's somewhere in there. In the old archives. Alright, so what we need to do is we need to look at this height scaler that's getting out there. So our scene resolution is going to be that. I should just do message log.trace on the height scaler. Is it message log.trace? Yeah, lowercase t. Right. Yeah, we'll just export the idle. Yeah, let's just. So let's see what is width scalar. Yeah, so the width scalar is 151 and the height is 80, which is wrong. So I guess maybe we should be using the whichever one's greater. This isn't even used here, is it? So I can probably just take those two out. Well, I think it's going to be whichever one's greater is what we're going to be using, so... Are we actually using Y-scaler anywhere? I mean, we were using it one place there. The Y is... Well, the Y was correct. So it's really just the height scaler and width scaler that are screwed up. So it's just going to be, if width scaler is greater than height scaler, then we're just going to set height scaler to width scaler. Otherwise, same thing. If we're going to set width scaler to height scaler. Because I think what's happening is Toon Boom works off of different units than a lot of other things, so we have to just go with what their math does, which their math does not always do what I want it to do. It does what it does, which can be frustrating at times. It's not a game package though. So yeah, we can see after there that we now have the correct width and height for our objects. So let's re-export our duck. He's not a duck though. He's a fat sack. And if this import goes well, then I'll see if I can dig up some of the code for that thing. Alright. So that looks correct. So let's go re-import and see what he looks like. Yeah, it's almost midnight here. It's 11:30. It's a perfect time to get started on your workday. Well, at least it is for me, I guess. So it looks good, all except for air falling. And that's because I didn't rig it. Easy enough. That sounds like non-fun. Let's see, it's gotta be in here. So I guess what we did is we had all that stuff, but then we kind of overwrote it to make the other game, so we don't have like the super old code for it, is what it looks like. Which kind of sucks. Yeah, we have the duality RC file there. We don't have the actual code for it anymore. Yeah, that's unfortunate. That code is now lost to time and space. That's what it looks like. Well, damn. There's probably a copy somewhere. Shit. But I certainly don't have it. So what happens when you rely on version control too much is you don't always archive absolutely everything. So let's re-import that guy. And it looks like we've all got the right collision on these things now. Well, let's take a look. This looks a little taller than I would expect. Yeah, it's a bit bigger than we'd expect, isn't it? Like it's both bigger horizontally and vertically by a factor of something. Yeah, this is what happens when you change your rigging objects. So let's see, let's estimate. This is going to be there's a bit of a problem here, isn't there? Not only is it's correct in the Y, but it's wrong. Its width and height is wrong by a factor, but it's shit. Yeah, this is we're now off by a magic number. What the hell? This is what happens when you use something that does not consistently keep its frickin' scale proper. What's happened is Toon Boom has exported, and the size of this object, we can't define the actual pixels. We also cannot get the actual pixel size of this object inside of Toon Boom, even though it has like a robust scripting interface. We don't know how big this thing is, like 100 pixels by 100 pixels. Really, I just know its scale is 1. So shit. So if it's off, like we've got the right pivot point, is what it looks like. So this should be right here. It's like half the height, isn't it? Did we just... What is going on here? What is going on here? I just making mistakes all over the place? I think I might be. Well, welcome to figuring out what is wrong with our import pipeline 101, and the answer is everything. Basically, Toon Boom Harmony is what we're using to actually animate our creatures, and we're trying to rig up stuff inside of Harmony so you can actually like draw where the pivot point should be. You can draw where the collision boxes should be and all that, because the 2D tools in Unreal are not very good for that. Especially doing it frame by frame or something, it's just tedious. It's beyond tedious. It's basically impossible to do. Just because it would take so freaking long to actually do it. Well, we can do it in Toon Boom. The problem is Toon Boom doesn't have all the information we need. It's not like Flash where you have a lot more programmatic access to all the things, all the information that you need. So this is what we were working with. And it looks like, while I thought that our Y was screwed up, it might be that our X is actually screwed up. Now our Y is screwed up by a small amount, and so is our X. Our Y is not, we're not tall enough. We're in the right place, but we are not tall enough and we're too fat. So the width and height scale is maybe reversed, like maybe we're applying the wrong scalar to the thing. Like we should be, maybe we got them swapped. Like the X, we have the X scalar, Y is Y scalar, width is width scalar. I mean, maybe they're just swapped. Like, maybe we just need to swap them, right? So So we'll take a look at it. Too many windows. You're so confused, what's wrong? The box is basically the box should be taller for the collision, and it should be narrower. So basically, we're applying a transform on this thing, which is taking a 1x1 box, and it should be properly, like, it should be a freaking square, right? But it's ending up not to be a square, and it has to do with the scene width and scene height of this thing, of kind of the export sprite sheet. There's like a scene thing in Harmony where if we go to scene settings, the settings for the scene in units are, the resolution is 1920 by 1024, which is non-square, so the coordinate systems that Harmony uses are not square. So it's not like, oh, okay, this thing is, X by X. It's this like relative bullshit units. So we have to convert those into real, actual, concrete units that make sense in, you know, non-animation land. And this looks completely screwed up. So yeah, that's not right at all. So we'll try swapping some of the other things around real quick before I have to actually just get in there and get my pencil out. Yeah, every time I think I got this Harmony export process working properly, it always throws some other random piece of crap in there to piss me off. You know, Adam will change some project setting and then all of a sudden things that worked break. And it's just like, if Harmony had actually just started from a consistent base of like, you know, the unit in the x-axis, one unit is one unit, or one unit is 100 pixels, or something along those lines where they had concrete physical units as opposed to these bullshit like arbitrary math that they actually use. None of this would be a problem. And it would just be like, oh, what's the size of the object? The size of the object's 5, and then you're fine. But that's not what it's got going on. So these things are square now, is what it looks like, which is good. So because they're square and the pivots are in the right positions, we can change our cosmological constant and hopefully it will scale it down to the right size. Because there's this like constant here that needs to be correct. And what we can do to figure that out is we can basically just take a look at where this should be and then where it is. So let's try 1.41. Because Adam re-rigged everything with these new, better rigging objects, and he tried to match the scales on everything, but it looks like he was unsuccessful at that. So there were two problems. Ah, man, so that's not correct. The pivots are right, but the location for the bottom left hand corner has not changed. X value is position times X scalar, so X scalar and Y scalar are wrong. Scene resolution. Let's take a look at the raw data real quick. So the X is -72, the Y is that. -72. So it should be 56, but it's not 56. So why is it 56? It's 56 because the scene resolution X scalar is going to be 1920 divided by 1024, or what are the scene? The units are 24, 24, and 12. And that's what I'm talking about, is it's going to be 1920 divided by 24. So these like X and Y units are